Hey guys, what's going on? And welcome back to R&D Technologies. The topic of today's video is going to be why you need 3D printing. Yes, you. Not some massive manufacturer or engineering firm, but you, the average consumer. You need 3D printing, and you'd be quite surprised on what you can accomplish with it. It may apply to your business or just something that you'd like to have in general, and why you should probably buy one. So thanks guys, stay tuned, you're really going to enjoy this one. So why don't we start off with a little bit of a history behind additive manufacturing. And additive manufacturing is just another term for 3D printing, but it sounds more technical, so a lot of people in the industry like to use that word. But I digress. So the first 3D printer was invented in 1984 by a company called 3D Systems, and they are one of our main competitors, but they invented a technology called stereolithography. While a very interesting technology, really the main additive technology that has consumed the industry is FDM, and that was founded by the gentleman who created Stratasys, which is a company we've partnered with to resell 3D printers. And Stratasys offers a wide range of additive manufacturing machines on the industrial side. And they've also purchased about 7 years ago now a company called MakerBot. And those printers are really great for hobbyists and education, oriented people like small schools or like middle schools and high schools and such. So FDM is fused deposition modeling, and it's basically a really, really cool hot glue gun. Now that's a really oversimplified version of FDM, but you basically think of it like this. You have your hot glue stick that goes into the hot end, and it's on an XYZ axis planes that are controlled with stepper motors. And using those stepper motors and a series of belts, the hot glue gun is moved, drawing out your 3D shape and stacking layers upon layers, thus creating your item. And I hope that description worked for you, because that's really the simplest way I can describe it. So when it comes to 3D printing, a lot of times when you have a file, you need to print support, because when you have something usually more than a 45-degree angle, the printer cannot print over thin air. So it needs to use a type of material, and this is for ABS and ASA, called SR30. And this is a soluble support. So when you print your item, you can dunk it into a mixture of different chemicals, and it'll basically dissolve the support material off. Due to that, there aren't many limitations to FDM 3D printing. The biggest thing is thin walls. Obviously the nozzles extrude a certain thickness out, and if the wall is thinner than that, then it's really tough for it to print it, and it sometimes won't even recognize the wall and won't even print it. And usually when it's one layer, it's really not ideal either. It needs to be at least two. One is really cutting it close. But also size. We offer one of the largest 3D printing FDM machines in the industry. It's called the Fortis 900, and that prints in 36 inches by 24 inches by 36 inches. We can't really do anything bigger than that, and if we do, we have to break it up into different parts. But 99% of the jobs we do don't even need fill up that entire build area. That's just for, obviously extreme cases, but it's great to have because we can print some really, really big stuff, and it's really cool to see them come out of there. And we can even print it in, all the different types of high temp materials we offer. So the takeaway from this is there really aren't any massive limitations saying that you can't print, this particular item or this particular item. You can print basically anything. So why would you choose additive manufacturing over different types of manufacturing, like CNC and injection molding? Now, CNC and injection molding have their benefits over 3D printing. However, CNC has a lot more limitations in terms of the material selections, as it's basically just a few different types of plastics and metals. And recently, there are additive manufacturing machines that can print in metal. But let's go back. So injection molding, first of all, the initial cost is very immense compared to 3D printing because you have to pay for somebody to develop that mold. So you're talking, tens of thousands to develop this mold. And then your cost per will be less than 3D printing, but you'll still have that initial cost of that mold to begin with. Whereas 3D printing, you can just design the 3D file, send it over to us, and we can print it up for you. But there will be a time where 3D printing does become more expensive than injection molding, because eventually that high price that you get with the injection molding and the low price of the 3D printing initial cost, the cost per being more with 3D printing, will eventually meet the injection molding, which is why 3D printing is great for short run manufacturing and not long run, and that's why you need to usually get into injection molding. Now obviously, short run is relative depending on the item, but we've done orders, of quantities of thousands before, and it's great because let's just say you have this one-off item, and sure, you could get it injection molded, but you don't need it immediately. 3D printing is great for that because we can produce the parts, and as we produce them, send them out to you and constantly make them, and it's great, and it's sort of like a production line. So that's why 3D printing is better than injection molding in some cases. Now, CNC machines are a lot less practical than FDM 3D printing machines. They're a lot louder, first of all, and secondly, you can't really create as many different things with it. So the reason why FDM is called, and 3D printing is called additive manufacturing, is because you start with nothing and you end up with something. You add and you create something. CNC is called subtractive manufacturing, where you start with a block of plastic or a block of metal, and basically a drill bit goes in there and cuts around and creates your item. Now, you could probably think that with a really, even a thin drill bit, your limitations are, vast and what you can create. You can create these multi-piece parts with CNC machines, but usually it's just rigid squares, circles, basic shapes for CNC machines. Whereas with 3D printing, the contours you can create are limitless. You can create a multitude of different things, and just with FDM, and there are higher resolution types of additive that are offered out there by Stratasys. And I'll get into that here in a minute. So there are two other types of additive that are offered by Stratasys: Polyjet and Stereolithography. Now, the first type, Polyjet, as you can see behind me, most of the stuff 3D printed here is Polyjet. And you can see, a vast majority of different items. With Polyjet, using a series of actually ink, like a regular inkjet printer, but it's actually acrylic-based resin, and it uses, the same types of colors that you see in an inkjet, cyan, magenta, black, yellow, but there's also a clear in there, and it mixes all these colors together, and you can create any color under the sun. 500,000 different types of Pantones and colors. You can see in this awesome pineapple, it got all the textures in there. And if you're familiar with Ghostbusters, this is in a clear material. This is really cool. This is just the clear green. And then, if you're a Star Wars fan, we have a Mandalorian here. This was printed on an Objet, which is a very affordable desktop printer, which is great entry-level industrial 3D printing. Also, we have this donut, which I think is from The Simpsons. I've never really watched the show, but there you go. And also this multi-part head from the Terminator. Just amazing the detail you can get. And that's a higher resolution 3D printing. that I had mentioned. So FDM can go down to about 5/1000ths of an inch, but this can go to 5/10,000ths of an inch, or 6/10,000ths of an inch. And the level of detail you can get out of these machines is incredible, especially with all the different colors that you can get. And for all you coffee fans, we have a Dunkin' cup in that cupboard over there. But it's just insane what you can create with these printers. Now with SLA, it's a little bit different and a little bit more of a meticulous process. So using a similar type of resin, SLA also uses UV lights like Polyjet does, but it's a lot more of a rigid technology. Polyjet does create some really cool parts, but the downfall of them is that they're very delicate. Whereas SLA, you can get the same type of quality, just in a little bit tougher manner. You can get some ABS-like materials. You can get some very strong flexible ones as well. The only thing is you can't print in the 500,000 different colors that you can in Polyjet. Also, SLA is a little bit of a more meticulous process in terms of post-processing. It's not just like FDM where you pull it off and there you go, you got your item. You have to clean it in isopropyl alcohol and then cure it again with UV lights. But those are the other two different types of additive that are offered by Stratasys that are really cool. And they have a range of these printers that I will tell you about in the next portion of the video. So what is the line of 3D printers that is offered by Stratasys? Well, we'll start on the desktop side and MakerBot. MakerBot was one of the first companies to really get into the hobbyist level machines, and they have been a leader in that market ever since they came into fruition. And Stratasys purchased them, I think it was about 2014, 2015, I might be wrong with that time period. But when they purchased MakerBot, they turned them into a company that was simply amazing. It gave a bunch of schools that couldn't quite afford the industrial side of 3D printers the experience of FDM 3D printing, and that's MakerBot only does FDM. But you have the Sketch, the Method X, and you can print in a range of different materials with MakerBots. They're great printers, and I believe they start a little bit over $1,000, which is a great price point that a lot of people can afford in terms of education market. And now we move on to Stratasys. Starting with FDM again, they have the F123 series, and the lowest one is called the F120, and it can print in ABS and ASA, but the great thing about it is the repeatability, reliability, and the customer service you get when buying it. I actually made a video about why buy industrial in our channel as well. You should check that out. I'll link it below. But then that goes all the way to the 370, and you can print in the 370, you can print in ABS, ASA, TPU, Dyran, EDS7, you can print in PC, ABS, a wide range of materials that are just great. And from there, it goes to the larger industrial. The 370 is more curated towards office spaces due to, its quiet and nature. Now we go to the other Fortis series, starting with the 380, and that's where you can really print in the really high temp materials in terms of Ultem, 1010 and 9085, and polycarbonate materials, not PCABS, but polycarbonate. And that's a 380, then you have the 450s, and all the way up to the 900, which is what I mentioned earlier. So that's sort of the FDM range of printers. Now when it comes to Polyjet, Stratasys offers the Object, starting with the 24, I believe, and then there's a 30 Prime. And then they just came out with a new printer last year or the year before, I believe, called the J55, and that is a great sort of 370-like office-based printer, but with Polyjet. And it has the capabilities of the J850, which is just a larger format, printing in 500,000 different colors, all the different textures, leather, wood, and whatnot. So that's sort of the Polyjet range as well. And there's also a J826, which is just a smaller variant of the 850, but a little bit larger than the J55. So that's sort of Stratasys's, the plural of Stratasys, I don't know. But that's their lineup in terms of what additive machines they offer. Finally gotten here. Why do you need 3D printing? Well, I hope you've learned something a little bit about additive and the industry in the past few minutes that I've been talking here. So with 3D printing, as you can see, you can accomplish a whole different feat of items, ranging from 3D printed pineapples to Terminator faces to donuts, all the way to jigs and fixtures and things that really are amazing, that are accomplished with high temp materials and amazing groundbreaking FDM machines. But like I said before, this isn't for some giant company, some manufacturer. This is for you, the average consumer. So with the lower end of our machines in terms of the 123 series and the MakerBots, they're great machines to get into additive on. Especially with the 123 series, you can really get into industrial additive manufacturing for a low price. And the things that you can accomplish are amazing. They're great for schools, architecture firms, small ones, and there's actually a business in Warwick that has 14 MakerBots and 3D prints cookie cutters with them. So that's just a great example of what you could use 3D printing for and not even know it. There's just a whole multitude of different things. There's a company that 3D prints shoes. There's companies that 3D print sunglasses. And it's not only a great thing for prototyping, in some cases you can use it for end-use items. Just like with the 3D printed shoes, people wear those, people buy them, and they're actually sort of comfortable due to the high flexibility that you can get from some of our machines. So let's go back to education. Why would a school want a 3D printer? Well, schools, obviously you learn there. And with these printers, which are the future of manufacturing, I think eventually CNC and injection molding will be almost erased by 3D printing. And I know that's a big thing to say, but the accomplishments and the forward moving part of this industry are amazing, and in the future this technology is just going to get even better, obviously. So you want to teach these kids about manufacturing and the manufacturing process, and this is great because it takes you through the whole different sort of circle of designing a product. Not only the prototyping process, but the end use. You can do both. You can create the prototype and the end use product with this type of manufacturing. And it's really easy to use as well compared to the other different types. Obviously, like I had mentioned, it has its quirks and it has its limitations compared to the other types of manufacturing, but this is the way to go. In my opinion, knowing how to use these machines is going to be as useful as being a plumber, a carpenter, a mechanic, because that's how big these machines are. And honestly, they're getting there right now. There are massive companies with hundreds of these machines running 24/7, and people that know how to use them, are really useful, obviously, to those types of companies. So that's why somebody like you would need it. Schools, architects, smaller engineering firms, but also the hobbyists. MakerBots are great for that. The Sketch and the Method X offer great high temp materials and bring down the technologies that's used in these industrial machines into something more compact that you can have at your house or small business. And the 123 series is great for that as well, just on the bigger, larger industrial side. So that's going to do it for today's video. I appreciate you guys stopping by and checking out this, and I hope you enjoyed. So I want you to check out our website, which will be linked in the description below, along with all of our social media pages where you'll find more great 3D printing content. And don't forget to click that subscribe button, like, and if you have any questions, don't hesitate to ask in the comments below. So thanks guys, and I'll see you in the next one.